Here we go with standard 7.6, sine and cosine functions, and they go together because they're so extremely similar. And we're going to first of all start off talking about a cycle. And what do we mean by a cycle? A cycle is one trip around our unit circle. So as you can see here, starting now, when we make one trip around our unit circle and we're looking at the sine function, we start in the middle, go to highest, lowest, and then come back to where we started. So this is one cycle of our sine function, which you discovered on your own. It's one trip around the circle. It's the shape of the function when you make one trip around the circle. For cosine, you see we started here at this highest point. We've gone a quarter of the way. We're in quadrant 2 right now, below the x-axis. We're in quadrant 3 now, below the x-axis, but now headed back up. And then right here we're at 0, and then we're in positive numbers for cosine, and we make our way back to the top. So this is right now, that's one cycle of cosine. And so one cycle of cosine and one cycle of sine look different. You see, so from here to here, 0 to 2 pi, here's one cycle of sine. Whereas if it's cosine, we start at the top, we go down to the bottom, we finish at the top. So a cycle is, didn't come up there, is basically one trip around the circle. Around the circle. That's what a cycle is. Now, when you make one trip around your circle, we have to look at this a little bit deeper. And let's talk about amplitude next. As I went all the way around, the highest, let's go back to sine real quick. The highest value I had was 1, and the lowest value I had was -1. And we need a term for this. Notice we went the same distance up as we did down, and we're going to call that our amplitude. So our amplitude is going to be the height. And the key is it's the height from the midline. Height from midline. So you can see there's this middle right here. So we go 1 above, 1 below, and therefore our amplitude is 1. Now watch over here. If I click on this A, whoop, my amplitude is getting higher. My amplitude is getting lower. So you can see, and you should have go ahead and write this right down right now, y equals A times the sine of f times theta. This A is your amplitude. It is the height. I'll pause it right now. A is 1.327, therefore the height is 1.327. It's the same height above the midline and the same below the midline. You can see right there, -1.327. So the bigger the number in front of A is 2.67. There we can see this height is 2.67. The greater it goes, the higher the amplitude. The lower it goes, the lower the amplitude. And no, it doesn't make a difference if it's sine or cosine. You can see right now this 0.626 is the height right here and right there from the midline. What happens if it's negative? Well, now instead of starting above the midline, I'm starting below the midline. So instead of starting here, curving down and finishing back up at the top, we start at the bottom. But this number in front, A, that's your amplitude. The amplitude is just like the Ferris wheel in that it's based off of the size of the Ferris wheel, and so this circle could be a different size, different radius, and we could have a different height. So now let's talk about domain and range. Well, as we've been saying, the only thing that stops me from continuing to go around the unit circle is, well, mathematically nothing stops me. I can continue this wave on and on. It can go on and on and on and on. I go around the circle, around, 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 around forever. So the domain for sine and cosine, the domain for both is going to be negative infinity to positive infinity. Nothing stops me from going around my circle over and over and over again. Where I am restricted is, well, we don't go up forever, we don't go down forever, and what's that going to be based off of? Right now, how low do we go right here? -2. How high do we go? +2. So in this case, my range is -2 to +2. That's as low as high we go, and yep, the amplitude is going to play a major factor there. So we've talked about domain and range. Okay, so the last thing we need to talk about is period and frequency. And so frequency is multiplied by our angle. So I'm going to click play here and see what happens. So let's slow that way down. So notice as this F changes right here, as it gets higher and higher, what's happening? It's squinching up. It's getting closer and closer to where one cycle of cosine, instead of being all the way from 0 to somewhere here around 2 pi, I can go through one cycle, one trip around my unit circle, and be done right here, right after I've gone 90 degrees. And so there are more trips around my circle in my frame right here. Whereas if I stretch it out, we can't even see one cycle of cosine in our picture frame. I'm going to go back to sine real quick just to show. Again, it's the same impact. It doesn't matter. So let's be a little specific and talk about this. So right now, the period is 2 pi, because the period, here's our definition of period, it's the length of one cycle. So in the case of here, one cycle, I start at 0, I go up, I come back down, and I finish back to where I was. That took place over the course of 2 pi, and we've been talking about that for a while. The frequency is how many, so basically how often the cycle occurs. And these two are related to each other with the simple equation period equals 2 pi over frequency, which in turn means frequency equals 2 pi over period. So they're inversely related to each other, which means, so I'm going to have my frequency go up. So this number went up. It's more frequent, and therefore, because it's more frequent, the length of a cycle is shorter. The more frequent, the shorter the cycle. The shorter the cycle, the more frequent we are. So let's look at this mathematically. I have the function y equals 3 times the sine of theta. Right now, because I've been paying attention, I'm learning, I know my frequency is 3. The frequency is 3. So let's look at this. 1 cycle, 2 cycles, 3 cycles. So from 0 to 2 pi, I went through 3 cycles. If I want to know my period, I'll just simply do 2 pi over the frequency, which is 3. And as you can see right here, we go through 1 cycle. And this distance right here was 2 pi over 3. All right, here we go. We have y equals 2 times the cosine of 4 theta. The amplitude I should know right now is right here in front. The amplitude is 2. The domain for all these functions is negative infinity to positive infinity. And the range, since the amplitude is 2, I know it's going to go between -2 and +2. So the range is -2 to 2. The frequency is the number multiplied by theta. So the frequency is 4. And my period is found by doing 2 pi over 4. So my period is pi over 2. One cosine cycle will be finished. I'll start right here at 0. And by the time I get to pi over 2, I'll have gone through one cycle. So I've gone all the way from here down and up and through right here. One cycle will be in this distance of 2 pi. So I'll go over here, I'll click the button, and boom, I was right. You can see right here. There's one cycle, and there's 4 of them. 1, 2, 3, 4 over the distance of 0 to 2 pi. So there's our standard 7.6. We can figure out domain, range, amplitude, period, and frequency by looking at the function or by looking at the equation of the function.